Hello everyone, my name is Samuel Iniesta. I'm a professor at Polytechnique Montreal, and in this series of videos, I will be presenting how to use Deepsoil. Deepsoil is a ground response analysis software developed at UIUC, University of Illinois at Urbana-Champaign, by Professor Youssef Ashash and his team. This software is used to do site response analysis in 1D and assess the potential for site profile to amplify or de-amplify seismic waves. In this first video, I will be providing a general introduction to the software, and in the subsequent videos, you will see how to run a complete equivalent linear and nonlinear analysis, and also how to deal with the input motions. This is a relatively short introduction to the software. The intended purposes here is not to provide an in-depth theoretical approach to Deepsoil. This will be covered in the training session accompanying these videos. So the first step when you open the Deepsoil software, you will have the home screen and you'll have to pick the analysis method. So you'll have to choose between linear, equivalent linear, and nonlinear analysis. Linear should not be used in practice anymore. We know that soil behaves nonlinearly. And I would argue that equivalent linear is probably an approach that has certainly known limitations and probably should not be used also. But it's a good practice to run equivalent linear in parallel to nonlinear analysis. If you click on equivalent linear analysis, you'll see the following options here. So solution type, you can solve the equations into frequency domain only in an equivalent linear analysis. You have different soil models, and we'll go over these different soil models in the training session. So I won't dive into this today. You can see here that the preferred approach appears in purple, and that's the GQH model. Same thing for the hysteretic unloading formulation. And you have the choice between non-mazing and mazing. We'll see what that means in the session, but remember that mazing should not be used. The current version of Deepsoil is version 7. It allows for an automatic profile generation. What that means is that based on one shear wave velocity profile, Deepsoil will automatically generate many iterations of the same a variation of your shear wave velocity profile, so you can study the effect of a variability in your profile, because there's always uncertainty associated with your shear wave velocity profile. So by clicking on here, you would allow this. So it's a bit more complicated, and it's certainly an advanced concept, and one that would take probably more than a short video to talk about. So we'll leave that behind for now. Unit system, you have, of course, the English system or the metric system. So that's for the equivalent linear analysis. Now, you also have here the choice to use the nonlinear analysis, and you have a few more options that appear. First of all, you can decide whether or not you want to generate excess water pressure. You may be tempted to just tick that box because you know that soil would generate excess water pressure upon cyclic loading. But the truth is, it's only as good as your pore pressure models and your constitutive models that are being used in your analysis. And as we'll see in the training session, there's still a fair amount of doubt to have about the ability of these models to capture the surface waves. You can definitely capture the liquefaction triggering of these models, but maybe not the wave propagation. So I would leave that behind for now. The solution type now is time domain, just because in a nonlinear analysis you can't solve the equation of motion in the frequency domain, so I gotta use time domain. It's a bit more time consuming, but that's what you have to deal with. Soil models are usually the same, so GQH and non-mazing as well. And you'll notice here that in the complementary analysis, you can also run equivalent linear analysis, and I would strongly suggest to keep this box ticked so that you can also run equivalent linear analysis in parallel and compare both and see if there's maybe an error in your nonlinear analysis. That about sums up the home screen of a Deepsoil analysis. In the next video, we'll talk about this tab here, the motions that you can use in Deepsoil. Just a side note here, if you already have a profile, you can just click open profile, or you can use one of the saved profiles. You also have the folder in your documents where you can put the profiles there, and they will appear right there. So these will be your personal profiles that you've used in your projects. So you have different like example files here. I would suggest you take a look at the manual. The Deepsoil manual is quite complete and has many examples of all the different options. And I think it's a good reference for you who are starting with Deepsoil as well. So I'll see you in the next video.